And if you can go to full screen, Ron, please. Thank you.
All right, I'm back again. I hope everyone can hear me.
Yep.
The second presentation is about modeling steel loads. And I know that a lot of you probably don't have a steel mill on your layout, but steel is one of the most recycled materials in the world. And even if you don't have a steel mill on your layout, your railway could be transporting steel loads to your industry. Just to give you a little bit of background information about why I'm interested in this kind of stuff, in addition to all the years that I spent as a member of the Homes Club, in my spare time, I also spent 31 years at Stelco Hilton Works in Hamilton, being hired in the mid-1970s as a switchman in the transportation department, which included at that time 29 locomotives, over 450 employees, and more track than the TH&B had main line, all within an 1,104-acre plant. After a few years as a conductor, I joined management as a yard master and then was transferred as a supervisor into the truck department. So those 15 years in the field gave me a firsthand look at steel loads, both on rail and trucks. So here's just some possible open steel loads that you could have on your layout. Scrap comes in a lot of different forms. Bundles, which look like cubes of steel that have been squashed into little squares. Heavy melt could be almost anything that's been taken apart and can be recycled. Shredded scrap and stampings that often come from companies that make cans and things like that. But there's a lot of semi-finished products as well. Pig iron from the blast furnace, semi-finished steel such as slabs, blooms, plate, hot rolled coils, and different shapes, billets, rebar, bar shapes, rod coil, and even I-beams, H-columns, pipe, and rail. So there's a lot of different possibilities, one of which might work well on your layout. So I'd like to start by showing you some prototype examples of some of these loads, and then talk about how you might create your own loads for your layout. Here you can see a gondola that has scrap bundles. These are relatively small bundles, probably no more than about 18 inches square. It's probably galvanized material or possibly tin, but they're unweathered, which leads me to believe that that's what the material was that was baled into these cubes. Heavy melt steel could be just about anything that's been cut up as scrap and can be recharged into the steelmaking process and recycled. Here's a rotary bathtub gondola, originally built to haul coal in Western Canada, but these cars are now being seen more often in scrap service. This one in particular with heavy melt scrap. Here's some shredded steel scrap. Again, not a difficult load that could be made with turnings off of a lathe. And steel stamping scrap, again, from things like canning factories, etc., where they're stamping out parts. Here are steel slabs, and I got one slab on the bottom and 4 that are tipped to the side. You'll notice there's no blocking or dunnage. Here's a bulkhead flat car with a load of plate that's been strapped down with steel strapping into the stake pockets. Also note that there is dunnage between the plates. Here's some steel shapes, round bar in particular in a gondola. Now, I wouldn't consider this to be a loaded car. It's either in the process of being loaded or unloaded. I'm not sure which, but this would not probably constitute a full load for this particular capacity car. Here's some steel reinforcing rod or rebar, typically used in cement work to reinforce the concrete. Comes in different lengths. At the mill, it's made in 60-foot lengths, but the length is really dependent upon what the customer wants. So if you don't have any 65-foot gondolas on your layout, then just make shorter rebar and put it in a shorter gondola. Here's some more bar products on a bulkhead flat car. Here's rod coil. Rod coil is kind of an interesting product. And you can see there's a great deal of wood blocking and dunnage in this particular car. Not really sure why, because typically when we shipped out rod coil, there was very little dunnage in the cars because it really didn't matter if the coils touched one another. Here's some H-column on a bulkhead flat car. Again, you'll see that in addition to the pieces being nested together, they're also banded together with steel banding. There's blocking between the layers, and there's even 4x4s stuck into the stake pockets to prevent the load from shifting. Another interesting load with 2-foot diameter pipe. Again, lots of strapping, blocking between the layers. There's actually little wedges in the blocking along the sides to prevent them from rolling off. Here's an older 42-foot riveted flat car, but it's ideal for hauling 39-foot lengths of rail. There are temporary bulkheads that have been made out of wood at the end of the car to prevent the load from shifting, and some 4x4s along the stake pockets. Hot rolled coils are often moved in covered flat cars. Sometimes the covers get damaged and end up being cast aside. So quite often you'll see coils moved without the covers on. Now these are semi-finished products, so if they get wet, it really doesn't matter. When they get to their destination, the factory will unwind the coil and pickle it with acid to remove all the rust before they make their own product from that hot rolled coil. Here's just a different example of a type of coil flat car. These are 110-ton capacity cars, hence 6 coils. And again, just a different design car, fairly modern coil flat car. Also would be appropriate to potentially build some empty bulkhead flat cars or flat cars that were carrying steel products and are now empty. If they're going to be returned back to the steel mill, they'll leave the dunnage on the car so it can be reused. In this case, it's the steel bars and rods that held the steel plate to the car. So there's typically 3 steps to doing this. First, you need to build the car, paint it, letter it, weather it, whatever needs to be done. Then secondly, consider the prototype weight of the load and how it's going to be unloaded. That's really important to how to build the load. And finally, building the load with the appropriate dunnage. So how do you estimate the weight of steel? Well, a cubic inch of steel weighs 0.2816 pounds. Now, it's kind of an odd number. How do you remember that kind of number? Most of you are probably familiar with a Canadian Pacific Hudson that's home-based out of Calgary, 2816. That's how I typically remember that number. But let me give you an example. If you've got a pile of steel plate that's 9 feet wide, 30 feet long, and 1.5 feet high, if we convert that all to inches, It's 108 inches by 360 by 18 inches high, multiplied by 0.2816 pounds. The load would be just a little less than 100 tons. And so be careful not to overload the car. So let's talk about some of the variety of steel loads that you could create for your home layout. Here's a couple of bridge beams that are loaded onto a flat car, a little too long for the car as it's got an idler at each end. Interesting load. Let's start with pig iron. Pig iron comes from the blast furnace in liquid form, goes to a pig machine. A pig machine basically casts it into small pieces about the size of a big loaf of bread, as an example, just for reference. And you can see the pigs heading up the conveyor belt and heading outside to cool. This is a pretty easy load to make using evergreen styrene, 4x4, chopped to approximately 18-inch lengths, loaded into a gondola and weathered with rust. And you're wondering, like, why would I bother with a load like this? Well, steel mills with a blast furnace can create cold pig iron for foundries that don't have a blast furnace, but they do need a source of iron. So it's shipped in gondolas like this, and they can remelt it and reuse it for their particular factory. Heavy melt scrap can easily be made from plastic sprues, chunks of styrene, etc. If you're a styrene modeler, you probably got all kinds of little scrap pieces of styrene. Put them aside, keep them in a little box till you're ready to fill a gondola, and then you can just glue it in there, weather it up. Simple load to make. Here's a car of bundles in a 40-foot gondola. These were made from foil. You can use a rattle can and just lightly overspray a little bit of the foil so that there is some color to the bundles, but you don't need to do that. It could be galvanized or tin scrap too, and it would have virtually no color to it. These particular bundles were made just by using your fingers and squeezing them into cubes, but probably more accurately, they'd look better if they had been put into a vise and squashed into consistent sizes. They'd probably look a little bit more authentic as they come out of the baler in the scrapyard. So what exactly is dunnage? Well, it's used to secure the load. It's typically a wood product, often 4x4s, both for cost and strength. Sometimes it's flat steel bar, which can be reused, and steel strapping. Some cars actually have semi-permanent wood or steel bunks mounted into the car. So those cars, upon being emptied, would be returned to the mill. So they're in a captive service between the mill and the factory. Some of the tools and materials that you're going to need for some of these projects, things like different sizes of scale lumber, X-Acto knives, black electrical tape, and I'll explain why in a minute. I use Flowco gunmetal, but there are other products available nowadays that you could use to simulate the color of steel. One of them is something called the Seymour Cast Blast. If you know someone or know of a store that specializes in automotive restoration, it's a product that they often sell. People that are restoring things and want that piece of machinery to look like sandblasted steel will often paint it with a product like this called Cast Blast. So let's start with steel plate. Steel plate is often used in construction, the fabrication of locomotives, railway cars, ships, etc. Comes in a lot of different thicknesses, right up to slabs, which could be up to 8 inches thick. The other thing that would be important to this process would be to have steel banding for some of these loads. If you can find 1/64 inch wide chart tape, then that's a good alternative to what I'm going to explain here, but it is difficult to find. I make my own steel banding. It's really not that difficult to do. So I'll walk you through some of the steps. Start by taking a length of black electrical tape and taping it to the underside of the ruler. Now you can see in this particular diagram, the ruler and the black represents the black electrical tape. Then take a second ruler, flip the first one over and remove a 20 thou wide strip of black tape from the cutting edge of the ruler. So you can see how where the blue meets the black, there's actually a 20 thou gap. Next step, take a length of black electrical tape, in this case blue, and stick it down to a sheet of glass and trim the edge straight. Usually when I stick it down to the glass, it doesn't go down exactly straight. So the first step is to make sure you've got a straight edge to work to. Then if you push the ruler up against that clean edge, you're going to create a 20 thou strip on the blue, which you can then slice off with your X-Acto knife. So it's really not a difficult process. It takes a few minutes to set it up, and you can make pieces that look very authentic as banding. Here's some diagrams of different loads on different types of equipment. I found this in a book printed by the AAR. It was in our accounting office at work one night when I was in the office. So I turned on the copy machine and made a few copies while I was taking in my yard checks to the accounting office. Anyways, here's some wide plate on a flat car. You can see that there's dunnage between the layers of plate, that they're using metal banding and rods to secure the plate into the stake pockets on the side of the car. As I said, you also have to consider how the load is going to be unloaded at its destination. If it's a factory that has an electromagnet crane, then it's easy for them to pick up that piece of plate and set it off. But if they don't have an electromagnet, then they're going to have to put chains or even strapping underneath the plate, hence the dunnage between the layers. So how can you model steel plate? Well, steel plate could come in various thicknesses, as thin as 5 thou, as I said, up to maybe as thick as 8 inches, which would be almost 100 thou thick piece of styrene. You need to glue it into appropriate size piles. That's assuming that there's not going to be any dunnage between the pieces. Then you can either airbrush it with Flowco gunmetal or Seymour cast blast and lightly weather it. And I mean lightly, because it does rust as soon as it begins to cool, but typically it's in pretty good condition when it leaves the mill. It's not been laid around and very rusty. Some other interesting things you could add to the top piece are the heat number, the size of the plate, any shipping information, etc. And I'll show you some pictures of the model with those on it. Typically 4x4 wood strips as dunnage beneath the layers. And if you're going to use metal strapping, 15 by 40 thou brass strip works well for that. You can drill a hole in the end and use brass wire as tension rods. You can either oxidize that with black in it, or you could paint those with grimy black. So here's a load of plate on a 60-foot bulkhead flat car using metal strapping. There's dunnage between the layers. You really can't see the chalk marks on the top here, but the next picture is a little bit more evident. Looking down into a gondola, you can see the chalk marks, and these are just done with chalk to help the people on the floor in the plate mill to be able to differentiate the different pieces of plate for different customers. But just looking at some of the chalk marks, it says Stelco on it, okay to ship. There's also the size of the plate, 96 by 180, and a TC indicating that it's been torch cut to that particular size. On the right-hand side, there's a 6-digit number, which is the heat number of the furnace that it was made in, so that they've been able to check the metallurgical qualities of the plate to make sure that it meets customer specification. And some minimal blocking in this particular car. So again, another AAR sheet. Here you can see slabs loaded into a gondola, typically one slab down the center and other slabs along the edges. Ingots would be loaded down the center of the car. And again, be aware of the weight of the pieces that you're putting in there so you don't overload the car. Hot roll coils. And again, hot roll coils are a semi-finished product. If we look at the two coils down here in the bottom left corner, you can see that it has 2 belly bands going around the outside and 4 bands that go through the eye of the coil. So they're the steel banding that was made or could be made on your model using black electrical tape. There's also a tag on the side of the coil next to the eye that indicates the shipping information, the heat number, the customer, etc. And on the coil at the extreme right, you can even see the little red clip that holds the end of the banding together. Again, just some more hot rolled coils on coil flat cars. Now here's coils that are being shipped in an open gondola with some semi-permanent blocking. So this car is in captive service. I'm not sure who the customer is, but when it's empty, the car would be returned to the mill and reloaded. Now these are slit coils. And it looks like one great big wide coil, but in fact, it's actually a number of coils that are probably only 6 to 8 inches wide. That's what the customer ordered. He didn't want a 36-inch wide coil. He only wanted an 8-inch wide coil. So the coil is slit and then banded back together again for loading. Also notice that the coils are over the trucks of the car. Again, just a couple of diagrams of how these coils would be loaded and where the dunnage would go inside the car. So you can purchase steel coils. Walthers, for one, makes them, and I think there's a couple of other companies that have brought out steel coils. But you could make them yourself using 10-thou sheet styrene. Paper cutter makes it really quick because it's so thin to cut off strips. You're going to need a round bar that you can roll the coil around, about 1/4 of an inch in diameter in HO scale. A little bit of plastic cement, some gunmetal or cast blast, the black electrical tape for the banding, and some 6x6 scale lumber. So use the paper cutter, cut it into 3 scale foot widths for a standard coil. If your sheet is about 12 inches long, like most evergreen, you're probably going to need about 3 lengths to create one coil. Wrap it tightly around the rod and continue to wrap, and then glue on the next piece and then the next piece until you create a coil. The nice thing about this particular method is when you look at the end of the coil, you can see the layers of styrene. So it's not a smooth finish like some of the coils that I've seen produced that don't have what shows you the different layers of steel. Again, paint it, black electrical tape for the banding. And again, some coils have chalk and paint marks and shipping information. So here's a coil flat. The coils that are on the end, I haven't banded them yet, but just to show that you could make them in different diameters, slightly different widths, but they are scratch-built coils using styrene. The 3 coils on the opposite end are the Walthers coils, which I think are quite adequate. It is a little tricky to paint the banding, which is part of the coil, but with a steady hand, you can do that. And you can see there's also some chalk marks on that far right coil. Here's just a downward view into a gondola. You can see that there's 3 coils on each end and the appropriate blocking, again, loaded over the trucks. Okay, rod and bar products. Steel reinforcing rod or rebar is a really common product shipped from a steel mill. It's used in the construction industry to reinforce concrete. As I said, this is not what I would consider to be a full load, but steel bar can come in a lot of different sizes and shapes. It can be round, it can be flat bar, it can be hexagons, squares, even fence post, which is like a T shape. You probably are familiar with cattle fencing that uses fence post. All of those are common steel bar shapes. So making a load of steel reinforcing rod, I used steel piano wire and cut it into 60-foot lengths. If you're going to use steel piano wire, don't use your rail cutters, your pliers. It'll ruin them. Make sure you use like a lineman plier or even a Dremel with a cutoff disc. Make sure you take appropriate safety measures. You can airbrush it. Again, a little bit of gunmetal cast blast and a little bit of rust to weather it. And you will need some 4x4 strip wood for dunnage on the floor in between the layers. But you're also going to need tie wire to hold these pieces of steel rod together. What I use is multi-strand copper lamp cord or speaker wire, but it needs to be copper. So if you get an 18-inch length, for example, and remove the plastic insulation, it will provide a lot of strands of lamp cord, copper lamp cord wire. I use blacken it which is a corrosive, to weather the wire for approximately a minute. Because it's corrosive, be sure to protect your eyes and skin. After you take it out of the corrosive, you can leave it to air dry for a few minutes, and then you can cut those 18-inch lengths into shorter pieces that you twist around the bar tightly and then nip off the excess. So here you can see some 60-foot rebar in a 65-foot milgon held together with very fine tie wire and just a minimal amount of blocking underneath each layer. Now, this car is also done with piano wire, but I was reviewing some online YouTube videos and someone suggested using small diameter tag wire for this purpose. I've never tried that. I don't see why it wouldn't work. He claimed that you can buy tag wire off of eBay or Amazon, that it's very inexpensive. And it's really just used for tags so that you can attach it to other pieces of equipment. So it's something you might want to try if you can order it online. The other thing is, again, even though it's made in 60-foot lengths in the mill, it really depends on what the customer needs. So here's a 35-foot pieces of reinforcing rod or rebar in a 52-foot gondola. So the customer is going to dictate exactly how big the load's going to be. Rod coil. Rod coil is made in a steel mill. It's shipped out cold, so it's in rolls like this. When it arrives at the customer, They reheat the coil to straighten it out, and then use that material to make fasteners like screws, nails, bolts, etc. So it makes for an interesting load in an open gondola. Here you can see a gon that's actually got 3 rows of rod coil, 2 along the bottom, and then a 3rd row in the center. The one thing to be careful of here is if you're going to use real metal for this purpose as opposed to styrene, you can quickly overload the car in weight, significantly more than the recommended practice of typically 4 to 4.5 ounces for a 50-foot gondola. So how to make rod coil? So I take a 3/8 bolt, cut it short, drill a hole through it that I can put a common nail through, a little finishing nail, maybe I should say, and a washer. Then using some 28 gauge wire, I wrap 3 layers around the bolt, pull out the pin, slide the washer off, and then with 2 tie wires, slide it through the eye of the coil and twist them off. And of course, again, you need to do some painting and some weathering. But again, not a difficult thing to do, a little bit time consuming if you're going to need about 25 of them to fill a car. Usually there's no dunnage in a rod coil car. It's typically 2 rows on the floor of the car. And as I said, there may be a single row on top, but be careful that that car may become excessively heavy. So here's a load of rod coil in a 52-foot gon. I said 26. Maybe I underestimated that. I can't really count quickly, but I would say there's more than 26 there. H-columns and I-beams, again, used in construction. This particular car is a bulkhead flat car, and you can see all the wood dunnage in addition to the steel strapping or banding that's being used. Again, you're going to need a bulkhead flat. Evergreen styrene works good for the H-column, and some lumber, 4x4 lumber, and the basic tools for some of the other projects, the black electrical tape, rulers, knives, etc. So cut the evergreen H-column to the appropriate lengths, paint it, weather it. I hand paint the ends rust. You'll notice in that prototype photo, for some reason, the ends rust much quicker than the outside of the beam or the column. Glue 2 nested pair of H's into a layer, and then band each layer with the steel banding tape. And then put 4x4s between each layer. They're banded in layers 1 and 2, then 2 to 3, then 3 to 4 to create a block. There's also 2x4 blocks above and below, and 4x4s in the stake pockets, often to prevent load shifting. So here's a car on again on a bulkhead flat. You can see all the extra banding that holds the different layers together. And although there's dunnage between the layers, there's also some little blocks that have been fastened to the cross pieces to prevent the load from shifting from side to side. We looked at this car a little earlier. Again, a relatively simple load to do using some scale rail. Here's an AAR diagram of how it's loaded in a gondola. This particular model was done on a flat car. So first thing is to cut some 39-foot lengths, which is a standard length of a jointed rail. Airbrush the rail, rail brown and a little bit of rust. If you're going to make a temporary bulkhead, you could weather that with some India ink and alcohol, and then you'll need some different sizes of lumber, 4x4s for the stake pockets, some 4x4 for horizontal dunnage, and some 4x4 for end posts, 2x12 to create the bulkhead. So here's a 40-foot flat car, 42-foot flat car with the temporary bulkhead and the couple of rows of rail. Steel pipe. Steel pipe comes in a lot of different sizes, depending on the customer's needs, and in different lengths. Here you see an 89-foot flat car with large diameter steel pipe. It's been painted to protect it from corrosion. Lots of banding, lots of blocking on a car like this. I use 3/8 diameter brass tubing and cut it with a Zona saw in a miter box. You could use aluminum or styrene tubing as well. If you use styrene tubing, just be aware that sometimes the wall thickness of the tubing is a little bit out of scale, and you might want to take a number 11 X-Acto blade and run it around the inside of the tube just to thin out the wall thickness. Paint it an appropriate color. It could be rusty, it could be painted to prevent corrosion. Then you need some 4x4 for the wood along the deck, the dunnage. And then some more 4x4 cut on 45-degree angles for blocks that prevent the pipe from rolling off the car. So you'll need some material to go between the layers as well. And then lots of black electrical tape or chart tape for the steel banding. So here's 11 pieces on a 60-foot flat car. You can see that between the rows, the dunnage, and then those 45-degree pieces of wood that have been fastened onto the horizontal dunnage that prevents it from rolling, and then all the steel banding all the way down the car. Just a different type of pipe load in a gondola. And again, just another car with a different type of pipe loading, using evergreen 1/8-inch tubing, painted black. Just a minimal amount of 4x4 dunnage. And that's about it. Here's Hilton Works taken by our company photographer back in its heyday from Burlington Bay. So I'll stop screen sharing here, and if you've got any questions, by all means.
Ron, once again, thank you very much. And I hope those of us who need loads for open rail rolling stock have found some ideas as well as some inspiration and how-to for making them. Open everything up to anyone who's got any questions or comments. Just while I'm waiting for people to formulate anything. Another source inexpensive that I've used for small pipe loads is stir sticks. So as I travel here and there and get coffee, I'm always looking to see what's being used. And I can't tell you of a particular restaurant or fast food facility, but every now and then you'll find these little tubes that are very inexpensive. And then you just have to look at whether the ends are in scale or not, as Ron advised us.
Yep, good tip.
Anyone else?
In the past, Harvey's restaurants use black straws, and they make very nice pipe.
I recall that. I remember collecting those.
Yeah, I have one suggestion on the baled scrap. A friend of mine has made them by crunching together the aluminum foil and then putting it into the end of a 1/2-inch socket, into the 1/2-inch end, the little square part.
Okay.
Pack it down nice and tight, and then you can just push through from the other end to pop it out.
That's a good idea.
Ron Trains and Things also has a video where he shows an approach. You know, if you want to watch TV and have your fingers doing something else at the same time, it's a good make work project, I suppose. Anyone else? Thanks, John.
Ron, I was quite impressed with your comments about not overloading the car. And first, when I heard it, I thought, full-size cars. And then really, you're right in that overloading HO or N-gauge cars, and all of a sudden your train's coming off the track halfway through, and you're thinking, what's going on here? But overloaded cars, very true. Thank you.
And all the shipments out of the plant all had to be weighed. So the shipping documents would match what the mill had written on the document. I mean, that's how we got paid by weight. So it was very important that was done. But yeah, a 70-ton car, you can't overload it. It has to have 70, less than 70 tons of material on it.
Yep.
Ron, another comment. I'm always surprised as your pictures and what I've seen on the railroad is how many of those H and I beams they can put on a car. They seem to be overloaded.
Yeah, I kind of thought the same thing, John, when I first saw those kind of pictures, but there's a lot of airspace in there too.
Mm-hmm.
It's not a solid block of steel. And I think that's why. And, with a little bit of mathematics, you could actually calculate how much an I-beam or an H-column weighs using that formula, and then figure out how many of them you could put on the car legitimately.
It just seems like a lot of load compared to a load of rebar or
yeah, exactly.
Never thought of it, but yeah, some of that, the volume is actually air.
Mm-hmm.
Yeah, it is.
Going back to the comment that Gerald was making, and factoring together the tip that you gave in terms of the building process, as I've got some kits yet to assemble of gondolas, I'm thinking what I need to do is calculate what the load might be, and then look at whether, in fact, I either leave the weight off that comes in the kit or use something else.
Well, that's certainly an alternative. I mean, if you want to build a car with rod coil, because you're using metal as the weight, as the load, that might be a way to be able to put an extra ounce or two into the car without overloading the car.
Other comments, questions?
Well done.
Who's that? Was it you, Bob?
Yes, sir.
Thanks for joining us, by the way.
I'm glad to be on here.
You're with the SLD, am I correct?
That's right. That's right.
Anyone else? Well, just by way then of closing off, and I'll stop the recording.